Okay, everybody, this is 14.3. I'm just going to go through 3 problems with you. The first one comes from that first section where we're trying to find the 6 trig functions. So I know I've got to find sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta, which I already know is negative 2 over 5. So I might as well come over and say that tangent is negative 5 over 2, reciprocal. Well, the problem is I can't find any of the rest of these without having the radius, because I know the cotangent equals x over y. But I also don't know which one's the negative. Is it the x that's negative, or is it the y that's negative? I need to figure that out. That's going to be found in this information right here. So let's go in, draw a quick sketch. Pi halves is right here, and pi is right here. In this region, if you'll notice either from your unit circle or from your knowledge of graphs, that if I go to the left, x has to be negative. If I go up, y has to be positive. So x is going to equal negative 2, and y will equal 5. Now I could come in 1, 2, 3, 4, 5, and put a dot and try to create the triangle. This would be 2, this would be 5, make that a negative 2. And I'm looking for the radius. Or I can just jump straight to the Pythagorean theorem, saying that negative 2 squared plus 5 squared equals r squared. This is 4 plus 25. So r equals the square root of 29. Okay? And that's important to me because I can use that now to finish solving these out. Well, the sine is always the y over the r. That would be 5 over root 29. But I know that I need that 29 up top, that root, to be moved up top. So I'm going to say this is 5 root 29 over 5, or over 29, sorry. Let's clean that up just a little bit. My bad. So it's over 29. Over here, the cosecant, it's reciprocal. If I take this version and reciprocate it, I'll get root 29 over 5. And that's simple. Here, I'm going to get a negative 2 over root 29, so that'd be negative 2 root 29 over 29, making this root 29 over 2, and I better slip the negative out front. Okay, so there's my 6 trig functions for something that has a cotangent of negative 2/5 in that region there. Then comes the difficult stuff, or at least the new stuff. This is not a simple, easy problem. That's part of why I chose it. If we look at this, the first thing I want to deal with is this. This is what's called a cofunction, because it's been shifted. It's been shifted to the left or right, as you might see it, pi halves. And so we're going to rewrite this just slightly. Secant of x sine of x plus the cosine of pi halves minus x is the sine of x. All of that will be divided by 1 plus secant of x. Now right here you might find that you're in a world of hurt. There's not a lot of great choices. How do I do this? Well, Mr. Welch is very intelligent and spent a lot of time doing this. So we just need to look for some things that they have in common. We did this back a long time ago, but hey, look, they both have a sine in them. Let's pull it out. So if I put sine of x out front, I would have the secant of x plus 1. And all of that's divided by 1 plus secant of x. And I hope you see it right now. If you don't, let me highlight it for you. This is the same as this, leaving me with the sine of x as a final answer. This is much, much simpler than all of this mess up here. Then number 34, again, one that's got a little trick in it along the way. I can't touch the right-hand side. I can only work the left. But I'm still going to do some sort of side work over here. So this is side notes, okay? I'll do some work over here from time to time. And it's not part of my actual substitutions, but it's important. First thing I notice, though, is I've got this negative here. I want to get rid of that. So this is sine of x over 1 minus, and I know that in a cosine, that negative is absorbed in the cosine, so cosine of x. So I haven't made much progress, but I don't have any negative angles anymore. The next thing comes from trying to figure out what in the world this even looks like. I don't even know what this really means. So I'm going to rewrite it in sine and cosine terms, because this is sine and cosine. Maybe I'm already there. So what I'm going to do is I'll say that cosecant is 1 over sine of x plus, that's what this stuff's coming to, cosine of x over sine of x. So it looks like my sines need to be in the bottom, and I need a cosine on top. Well, I started thinking, how can I exchange a subtraction problem for sine? Well, here's what I know. The only problems that have addition or subtraction in them, the only identities, are Pythagorean identities. Okay, I'm going to erase these notes because I'm not actually coming this way. This is just side work. All right. I know that sine squared of x plus cosine squared of x equals 1. And if I moved this cosine squared over, I'd have 1 minus cosine squared. It's a little different than this, but maybe I'm in the right direction. So sine squared equals 1 minus cosine squared. Okay? That substitution could work for me if I could find a way to come up with 1 minus cosine squared. Well, let me make this very clear to you. 1 is a perfect square. Cosine is a perfect square, and I'm taking a difference. So that old difference of squares that Mr. Welch really, really likes is back to get us again. So I'm going to multiply by the other half of the difference of squares. Be 1, whoops, doesn't look very good. It would be 1 plus cosine of x. On top, 1 plus cosine of x. And then all I have to do is do some distribution. Now this could blow up in my face later. It may not work at all, but I've got to try something. I know that this, as a difference of squares, will produce something like that. Maybe that's enough. So I'm going to distribute. 1 times sine x is sine of x. I'd be adding sine of x times the cosine of x. That'll all be divided by, well, let's FOIL here. We only have to do the f and the l because they're conjugates. 1 times 1 is 1. A negative times a positive is negative. And cosine times cosine is cosine squared of x. All right, so that's what I did to get to this line. But now I'm using this idea for my substitution. I did all that work to get here. Let's go ahead and do the substitution with the denominator. This is going to be sine of x. And I'm going to separate them because I noticed that the two answers here are separated. Okay? So sine of x over sine squared of x plus sine of x cosine of x all over sine squared of x. Okay, so I took the two pieces of the numerator and I separated them into two fractions because I want each of them to cancel on their own. Here I notice that the sine on top would cancel with one of the signs below, leaving me with 1 over sine of x plus, over here the same canceling would happen, leave me with cosine of x over the sine of x. Now, part of the reason that I did this work on the side notes is so I'd recognize when I have my answer. Right here, this looks the same, doesn't it? Now, I can't stop, even though I think these are all equivalent. I need to keep going just long enough to say that this is cosecant of x plus this would be cotangent of x, which is exactly what I was hoping to get. Cosecant of x plus cotangent of x. Did I change the right-hand side? No. I worked with it a little bit to kind of get a sense of where maybe the middle would be. You know, meet me in the middle somewhere. This means I've got my answer. Now, does Mr. Welch expect you to be able to do something as complicated as this on the final? No, but I want you to do difficult problems so that when a medium difficulty problem approaches, you can handle it, okay? Good luck, and I hope things go well for you. Bring your questions tomorrow.